In this problem, we're given the differential equation governing a circuit. We want to find out a few things about it. First, the cutoff frequency. Now, the easiest way to do this would be to put this equation in standard form, which if we divide out this leading term, we get dV by dt plus 1 over 50 V is equal to I of t. Our general form was dy by dt plus 1 over tau times y is equal to f of t. So 1 over tau is equal to 1 over 50. The time constant is 1 over tau, so omega sub c is 1 over 50 radians per second. In part B, we want the DC gain. The DC gain is the ratio of the output to the input as t goes to infinity. So this will be V at infinity over I of infinity for a constant input. So under this circumstance, we have 100 dV by dt plus 2V is equal to 100 times I. For a constant input, as t goes to infinity, the derivatives go to 0. So V at infinity is equal to 50 times I of infinity. The ratio of the output to the input is just 50, and that is the DC gain. Finally, we want to decide whether the circuit's high pass or low pass. We know the DC gain, which is omega equals 0. So we know the gain at 0 is 50. So now we just need to find the gain as omega goes to infinity. Let's convert this to the frequency domain. So we assume that I of t is some current phasor I, which is a function of omega e to the j omega t. In that case, V is going to have the same form. So this is going to be V as a function of j omega times e to the j omega t. If I take the derivative of this with respect to time, dv dt is j omega v of j omega e to the j omega t. Plugging all that into this differential equation, we get 100 dv dt, which is j omega v of j omega e to the j omega t, plus 2 times v, which is the voltage phasor as a function of frequency e to the j omega t. That's equal to 100 times I as a phasor function of frequency e to the j omega t. As always, the e to the j omega t's cancel, and solving for v of j omega, that is going to be 100 over this term plus this term, j 100 omega plus 2. And if we let omega go to infinity, y of j infinity becomes 100 over infinity, which is just 0. So at high frequencies, the magnitude of h of j omega is going to be 0. At low frequencies, it's 50. This is going to be a low pass filter.